I am Ajay, and I am working in miniOrange from past 2.5 years, and I am working in the endpoint security domain in miniOrange and with the product CASB. So today we are talking about enabling the zero trust and how it is important in the access control. So this is a little bit about me, which I just conveyed you. Nothing new over here. Let's move ahead with today's agenda. So today we will be talking about access management and access control. Next, we'll be moving ahead with role-based access control, why it is important and what role it plays in your real-time environments. Next, we have granular access control. And moving ahead with that topic, we will be going forward with endpoint security in access control. And at the last, we'll be having the zero trust factor, how it is used in access control is used in zero trust. And at the last, we will be having an interesting case study about the granular access control, and we'll be looking forward to it. Let's move ahead. So basically, what do you understand by access management? Can anyone have any ideas about it? Okay, so access management is basically managing your access based on the resources like policies, roles, and identities. So what are basically roles? So roles are basically like if I have a certain role like a software engineer, it is a role. Let's say there is another role like business analyst. So based on my role, I can be allowed to access certain resources or not. Then we have identities, and further we move ahead with policies like I can create certain policies like I am allowed to access my resources from a particular network or from a particular location or from a particular device. So all those are covered in your policies. So how the journey of access control is evolved. So access control, there were four traditional approaches basically in access control. The first one was attribute-based access control. In attribute-based access control, a certain attribute was passed in your request, like you have purchased some subscription. On that basis of your subscription, like you have purchased a movie on Amazon Prime, and you are just be able to access that movie because you have that attribute passed in your request parameters. So we can understand it by using this basic example. Next, we have a role-based access control, which is RBAC, and it is quite famous around the endpoint security domain. And in the zero trust, it is widely used. So what is role-based access control? Role-based access control is similar like if I have assigned with certain role, then I will be allowed to have certain policies applied on me. And based on those policies, I will be having my access to the resources. Next is discrete access control, which is called DAC. And in DAC, we just, based on the resource owner's permission, we are able to access the resources. Like you all have used the Google Drive or Google Docs. You just share the permissions over Google Docs to someone else. And only then, like you have three kinds of permission: viewer, comment, and edit. And based on the owner, the permission which is set by owner, only that permission set you will be having, and based on that you will be able to access that resources. So that is covered in DAC. Then you have mandatory access control. Mandatory access control is quite famous in earlier models where organizations had set certain policies on their employees, like they should be allowed to access from only their what we can say perimeter security is our main example of this thing. In perimeter security, they have a selected IP range in which they can just select the IP and they can access the resources through using that IPs. So in short, based on your organization level policies, you will be able to access the resources over here. So what were the benefits of the traditional access control? Traditional access control was quite simple and clear, and it has scalability in the static environments where there is no need of managing people, because once you create policies, they can be replicated in other environments as well. So you don't have a need to manage those. Next, it has enhanced security in specific contexts. What does that mean? It means like you can just generate a policy set, and based on that policy set, the context will be defined, and that context will be applied on the users, and they will be able to access those things. It is quite flexible, as creating policies in a static environment is quite easier as compared in the dynamic environment. Next, it is quite aligned to the organizational level policies. And at last, as it is in a static environment and it is quite easy to use, and it was quite cost effective. So cost factor was quite easier over here. So basically, if we are evolving into something next thing like real-time access control and real-time role-based access control, so there must be some challenges in the current approach. That's why we are evolving into the next phase. So what were the challenges? The lack of real-time ability was the biggest challenge. So if an system admin wants to restrict some user on the real time, they won't be able to do that in the traditional approaches, as the session once the session is being made, it has its policies assigned. So there were no system to basically just revoke their sessions, or basically just kick them out of their sessions based on their changes in the policies. So, but in cases of real-time access control, you can just quickly change the policy from the admin side, and those policies will be reflected in the real, and the user doesn't have to log out from their current sessions. Next, as the user doesn't need to re-log in again for their new access, it was quite inflexible. Since there were no overhead mechanisms, so what user is doing, that can't be monitored over there. So it requires lot of manpower to just monitor what the user is doing, what they are accessing, what they are trying to use, and all those kind of things. Next, we have limited context awareness and vulnerability to insider threats. Let's assume someone with lower level of access gets a higher level access by mistake of an system admin, and they won't be able to revoke their session, and they can just be an insider threat. They can just do any invalid operations they shouldn't be doing over there, like accessing some confidential files. So it was quite possible in the traditional approaches. So it was one of the biggest challenge over there. Then, because of all these issues, many organizations were facing the issues of compliances. They weren't able to get the compliance properly. So how the evolution of access control was done? Basically, there was a modern enhancement. The major key part which was missing was the real-time challenge in it. So we added the real-time challenge and adjust based on their contextual factors. And we can just modify those context parameters on the go and just change their policies and revoke their access if needed, or change their access if needed. That totally depends on system to system. So now comes the topic. We have talked a lot about our role-based access control. So what is RBAC? RBAC is basically assigning permissions roles within an organization. So there is a hierarchy. So upper management, there are super admins, there are normal admins, there are IT admins, then there are your senior software engineers, then software engineers, and so on. The list goes on. So not everybody have the same permissions. When we say there are super admins, so super admins can access any resource from anywhere. Then you have your upper management. They can also have certain level of access, but when it comes to a lower level management, they won't be able to access their resources outside their networks, or let's say outside their allowed zone. So what are the basic key components of RBAC? RBAC basically consists of following parameters like users, permissions, constraints, sessions, roles, and role hierarchies. Based on all these factors, we create the policies which we apply to the groups. And groups are basically the group of users, like what we discussed over here. Basically, there is a group of software engineers. There is a group of senior software engineers. So all those groups will be considered as a one, and based on those groups, we'll be applying certain policy sets. Now there comes a topic about the granular access control. Granular access control is basically like applying the policy on the fine-tune level, on the lowest level, how much we can just go to restrict the users. Let's say there is a Google workspace and you want to apply a granular access level, something like that. Okay, there is Drive. You just don't want your users to use Google Drive. So how we can implement that? So basically, when you just purchase a Google license in an organization, you by default get all the application access, but you do want to restrict those access to those certain users. So how we can implement that? So all these situations come under the granular access control. And there are certain parameters in granular access control. First one, user identities and roles. In this, we just identify the users, and based on those identities, we apply the roles to those users. Next is device health and type. Device health and type is basically, is your device validated, or we can say verified device. Let's say you are using your office systems or you are using your personal device. So those are also considered under the parameters in the granular access control. So let's say you are only allowed to use your office device. If you are trying to log in with some other device, let's assume your personal device, you will be unauthorized access and you will be just blocked from logging into your devices. Next, we have behavioral analytics. So what is behavioral analytics? Basically, you all might be using ChatGPT. So everyone has a way of talking to ChatGPT. So let's say I start my conversation with ChatGPT with hi. Someone else is starting with direct question. So there is a change in behavior over there. So that can also be identified. Similarly, you are using your devices from a certain location. That is your behavior. Let's assume you are doing remote work. So you are just using your device from a particular place at your, let's say your home. Then suddenly you just go to some different country and trying to access that. So that also considered under the behavioral part. So you have just changed the behavior of your access. Next, we have geolocation and time access. So geolocation is similar, like if you are accessing from certain location or you are just restricted to use from certain location, that is considered under the geolocation. And the best example for that would be, have you heard about the locks in cars? Basically, there is a geolocation lock in cars lately, we have seen. So in that, if a car goes outside the 5-kilometer radius of that geolocation lock, it automatically turns off. In a similar way, access control also works. If you are using let's say I have given you permission to access your Google Workspace only from India. So as long as you are using an Indian IP or you are in India, you will be able to access. And at the moment you change your geolocation, you will be just completely restricted from getting the access. Next, we will be connecting RBAC to real-time controls. How we can do that? How it enhances the RBAC. So first of all, real-time policy enforcements, what we already discussed. The dynamic role adjustments. So on the go, if we are changing some role of a person, let's say I am an IT admin and I am seeing certain user is using their application, their resource in a different vague manner. So I can just change their permission set on the go and it will be reflected and they won't be able to access it anymore. So the question arises, why real-time matters? So real-time matters to resolve all these kind of issues where with the policy management is of crucial need. Then we were talking about the endpoint, just what we discussed in the device health part. We discussed about the endpoint security, how endpoint security plays a role in access control. So basically, endpoint security is like, there are certain things like CASB, DLP, MDM, and there is unified endpoint management. There are many more things. So if you have to secure your cloud applications, you use Cloud Access Security Broker. In this, you are securing your SaaS applications like Google, Office 365, Atlassian, Shopify, and many more. The list goes on. In this, if you want to apply certain restrictions, let's assume you are a UI UX designer and I have purchased a license for you, for a Figma license for you, and it is a quite costlier license and I don't want you to use it in a personal manner. So I can just restrict you based on my office network. If you are just trying to access it from your office, you will be able to access it. And let's say if I want to protect some data, if I don't want my users to download data from their OneDrive or from their Google Drive, I can just restrict them. So all these kind of securities comes under the cloud access security broker part. And next we have the data loss prevention. So data loss prevention is like securing your device, OS, and your physical endpoints like your USB drive, your LAN cable, your HDMI cable, all these ports. So does the user have those permissions or not? An IT admin can define all these things. When we come to the third key component of our endpoint management, that is MDM, mobile device management. So we are securing all these applications in cloud application, which is over your laptops, and we are using the DLP to securing the OS level security and the applications. But what about the mobile devices? Lately, we are using the mobile devices as well. So securing your mobile device is a part of MDM, and over there, we just provide the security based on the policies like profile management. Over there, we just make the profile of the users and apply policies like they can install certain applications only. They cannot install, let's say, I have given some iPhones to my end users, and the basic example would be we all have played PUBG a lot in iPhones, and that was too good. So let's say if I restrict all the games, the user cannot install any games or any certain set of applications, like they cannot install the entertainment applications. All these are included in the MDM policies. It basically manages your mobile devices on a granular level. So how does it all connects to ZTNA? Basically, access control is a part of DLP, CASB, and MDM. It is a subset of that. And when we come to the endpoint security, which contains CASB, DLP, and MDM, endpoint security is also a part of a zero trust network. And when we say what is zero trust is basically like trust nobody. Always verify. Why there is a need of zero trust? As there is a drastic need of enhancing the security and securing your endpoints, securing your management, securing your data, it is quite much required securing all your private data and all your confidential data. That's why we need a zero trust architecture. Next, we have few key features of a zero trust architecture. First, we have conditional access. Let's take an example to understand what would be the conditional access. So conditional access can be like, if I am continuously working on my device and I won't be restricted in this scenario. Let's assume I just take a walk and go away for a lunch and my device is kept open, my session is open. So in this situation, we can just push a policy like, if when the user comes back and tries to access the application, they can re-authenticate using the multi-factor authentication. Or if there is an inactivity of more than 4 hours or 5 hours, the session could be terminated. Or there could be a notification sending towards your mobile devices that your device is open. Just switch it off. All these kinds of things are considered under the conditional access part. Next, we have least privileged access. Least privileged access in ZTNA means a user should only have that much permission which is needed. Nothing more than that, nothing less than that. So that is considered under the least privileged access, because if by mistake you have certain permission which you were not supposed to have, you can make some unauthorized things which was not allowed in your organizations. So it is a key factor in zero trust. Next, we have dynamic adaptation. Dynamic adaptation is like adapting based on your behavior or adapting based on how you are using the devices, what you are doing. Let's say you were downloading files from your drive. You're trying to download confidential files from your drive. And I have put a policy, if some user tries it for first time, they will be blocked. If they again try to use it two, three more times, they will be blocked. But after 4 or 5 times, their session should be revoked, or they should be prompt to re-authenticate, or the IT admin should be notified as they are trying to access something which they are not supposed to have. So that all things are covered under the dynamic adoption part. Last, it is the integration with CASB, DLP, and MDM. So Zero Trust consists of all these things. And next we'll be heading forward with a case study. So there was a law firm with whom I worked, and the use case of the law firm was they were using Google Workspace as their environment. In that, they were having certain issues like, so first of all, they have the informations like personal information, financial data, case-specific data, corporate client information. All these data was their confidential data. They don't want their employees to access these data from unauthorized places or unauthorized network, or we can say unauthorized devices. So, but they did. They created a system like their law firm employees should access the laptops. Basically, those devices were user devices. The employees were owning those devices, and they wanted their users to connect it through RDP and further connect it to their Google Workspace. But there was an issue. So if you can just connect to their remote, if you can connect to your Google Workspace through remote desktop, but you can also connect it directly. Who is there to stop you? There is no one can stop you. So, and you can access all the files, confidential files, and everything you will be able to access. So how CASB was able to secure these data? So what we did, in front of their Google Workspace environment, we created a security layer. And what was the role of that security layer is that we were enforcing their users to use the RDP IP to access their Google Workspace environment. So what happened, if any user is trying to access it from the RDP IP, they were able to access that. But when they were trying direct access from their user-owned devices, they were restricted directly based on their IPs. Now comes the question, how granular access CASB could provide. In this case, they were having one more challenge, like they wanted to have access of Google Meets, calendar, and contacts from outside the network as well in their Google Workspaces. Why? Because they can have meetings in an odd time. So, and they can schedule some meetings in odd times there after hours or somewhere. But they wanted to secure their drive where they were storing all their confidential data, and Gmail where they were having conversation with their clients, and chats and hangouts. All these files were stored, and they only wanted the access through RDPs only. So this much granularity a CASB solution can provide. We put some restrictions, and based on those restrictions, we allowed the access from for the Google Meet, calendar, and contacts from anywhere, and for the rest of applications, we provided the access from RDP only. Next, there was another challenge. The other challenge was there were system admins also in those organizations. So they wanted their system admins to directly bypass this security, and they should not be going through the CASB solution. They should have a direct access to this solution. So this was also be provided. And this is what when we talk about the granular access, this is called the granular access. Then IT admin can access it directly, but a normal user has to go through your security channel. So this is how it works. So what is the benefit of real-time granular access control? Why, if there is a need of it? So it basically improves the response time of an action. How it improves? So in the real time, it applies the policy, and if it was a manual thing, a system admin has to check all the things, and they have to apply certain policies over the user and restrict them. But if it is in a real time scenario, it would be an automated process. As the system detects it, they will be just directly blocking that request. Next, it was in seamless integration, and further ahead, it reduces the risk of data breaches and insider threats. So, as we have defined our groups, and based on those groups, we are attaching the policies, and it's not a manual process anymore. So, it is predefined processes now. So, the risk factor also comes down. And after that, the compliance part also increases. When you resolve the previous issues, the challenges which you are facing, we can have the compliance like GDPR and HIPAA. It became easier to get those compliances. So how we can implement the strategically? So current access and current policies are based. We can just basically assess how we can define the policies or how we can define the gaps in our current infrastructure, and based on those policies we can apply the restrictions. After that, we can just build up our own RBAC. Basically, we will be just creating our roles. An organization can have a number of roles. So, and based on those roles, we can attach the policies. So there comes a concept of role priority. So which role should be prioritized? Let's assume I have 2 roles. I am a speaker, and let's say I am a volunteer as well. So which role should be put first? So that can also be defined in your role-based access control. Next, we have, when we implement these policies using our granular access control and RBAC, we just apply it over our endpoint security part, and further we are applying that endpoint security in the zero trust environment. It basically enhances your security. So this was a major thing for our zero trust architectures. Next, deploy endpoint security tools with like CASB and DLP that we already talked about. And at the last, monitor and refine policies continuously with real-time analytics. So this is also an important factor. So as long as you are using the SaaS applications, you have something like, basically there is a way of accessing, and there will be a UBA, user behavioral analytics score, and based on that score, the real-time analytics can work. And how it can work? Based on your UBA score, there will be a threat detection point. So if your score goes up to like 10, so you are using it perfectly. And let's assume your score goes to somewhere near 2 or 3. So it will just basically detect, and it will just detect an anomaly, and based on that, you will be restricted for further accessing those things, and it will all be applied in the real time. And we can just provide that auditing reports to your system admin that some unauthorized access or unusual behavior has been detected in your environment. So the key takeaways for this session would be like, we learned about the access control, how it evolved, and where we are using those access control, and further we connected it to the real-time access control, and further at the last we connected it with the zero trust. So does anybody have any questions for this?
Hello. You were talking about the traditional approaches of like access control, right? Can you please go back to that slide? Is it possible? Okay, yes. So this mandatory access control, in that, can we connect the force authentication with this that we have in single sign-on?
Force authentication is also a part of mandatory access control. So basically, what is force authentication? Every time you just try to sign in to any other application. So we all have heard about the single sign-on. So single sign-on is like, you just identify yourself by your identity access management, and further you can log into any applications. But when comes a case of force authentication, in that case, every time you log into any of the applications, you have to re-log in. So that also comes under the part of mandatory access control.
Okay, thank you.
Hello, I have one thing to ask. Like, you have mentioned role-based access control, which is RBAC. So, and
can anyone just increase the volume, please?
Okay, can you hear now?
Yeah.
Okay. So you mentioned the RBAC. I wanted to know about the TBAC, where there is a just-in-time and there is a time-bound access. how both can be utilized apart from RBAC when we need access for a particular, or we need to give access for a particular time period.
But did you say T-back?
Yeah, time-bound access and just-in-time. How you can differentiate both of them?
So role-based access control and time-bound based access control, they are slightly different because when
I think, my main question is, what is just-in-time access? Just-in-time.
Just-in-time access.
Yeah. Okay. And how it is different than time-bound access?
Time-bound access.
Yeah.
Okay. So I have worked with time-bound access, but just-in-time I am not sure about. But in the cases of time-bound access, you are just allowed to have a access based on a certain time durations. So the best example would be for it like session-based access. If I just allow your session to persist for 1 hour, let's say I am just giving you certain access. I am giving you a security token, basically. In that security token, I will be just assigning you access for 1 hour. Let's say I have given access of an application like Figma application. I have given you the access and I am only giving you access for 1 hour. As long as you are in that time duration, you will be able to access those things. But how it differs from the role-based part, if I have given you the access of Figma, you will be having access of Figma completely based on your restriction policies.
Persistent access.
Yeah.
That is a persistent access when you say.
That persists.
Okay, maybe just in time, something you haven't heard. I wanted to know from that perspective. It is something which is really confusing for a lot of people. But
Okay.
that is fine if not aware about the just in time. It's not that kind of straightforward, I guess.
Yeah.
And not everybody is using.
Yeah. Basically, they are using currently attribute-based restriction is widely used in your CMS.
Yes.
Then we have, when it comes to the security thing, many of the organizations are moving ahead with two things like granular access control and the RBAC. And the combination of RBAC and granular is also in craze right now.
And how you are different from the RBAC perspective, how you are differentiating somebody is not having the elevated access persistently?
So basically, to identify, first of all, when the user logs into your system, there are some attributes. So in identity access management, you define a role for a particular user. And based on your group priority, or we can say role priority, so there are two things. You can just define the policies based on your roles or based on your groups. So we just take a group priority or a role priority, and based on that priority level, we apply the access control. So whatever the parameter is passed in the login flow, we just apply the security token, which consists of your access control part, and based on that access control part, we just give the permissions to the user. So it persists as long as that security token is valid to them.
Okay, so in that case, it's not a persistent access.
No. So
we can do that with RBAC?
Yeah.
We can do that with RBAC?
Yeah, we can do that. We can just increase basically there is one thing called you should re-authenticate yourself from every 14 days. There is a very good saying about that. So you can just configure, it's under your control. You can just configure it for 30 days, let's say 60 days. So some applications force re-authenticates after certain duration. Let's say Google, Gmail, you might be using Google. In the Google, the session persists around 30 days, 30 to 45 days. It is unusual time for Google. But in an organization, there might be a need that after 5 days, they should re-authenticate, or after 7 days, they should re-authenticate. So all that things can be covered under the role-based access control. So some users might have to re-authenticate, some might not.
Okay. So if role-based access can achieve this, then why we need time-bound access?
So time-bound access is also covered in the security policies of RBAC, because but you were saying like the time-bound access, we just provide your TTL access, time to live access, basically. So that is also one of our policies under the RBAC. In that we define a token token life, in which the token will be allowed to use. And after that, we will be just invalidating the token and forcing the user to re-authenticate or take permission again to get the access of that certain resources. So it is basically a subset of that. Not exactly complete role-based access, but it has slight policies of those things.
Okay. Thank you.
Thank you. Any other questions? Thank you guys for joining me.